Space is full of incredible things: planets, stars, galaxies. We all know how amazing and strange the universe is, or do we? See, there are some things which are strange, at the very least. For example, imagine something heavier than our sun, squeezed into a sphere smaller than a city. This is a neutron star. It forms when a massive star reaches the end of its life and explodes in a supernova. After the explosion, the star's core collapses under its own gravity. The pressure becomes so extreme that protons and electrons combine, forming neutrons. Gravity forces the neutrons closer, making the star incredibly dense. So dense that it contains over 300,000 times the mass of Earth in a space smaller than many cities. A spoon of neutron star material would be roughly equal to the weight of Mount Everest. Who would have thought that stars could become crazier after exploding? When a massive star explodes, more massive than one that forms neutron stars, it can leave behind a black hole. Now, they are pretty crazy themselves, but they are nothing compared to the largest black holes. The largest black holes in the universe literally could not have formed this way. They're simply too massive. A normal black hole, also known as stellar black hole, range from 5 to 20 solar masses, while the black holes at the centers of galaxies can reach billions of solar masses. Yes, you heard that right, billions. These giants are called supermassive black holes. Almost every large galaxy, including our own Milky Way, has one at its center. So how did they form? The truth is, we're not entirely sure. Scientists think they may have started as smaller black holes that slowly grew over billions of years, or they may have formed through a completely different process shortly after the Big Bang. Whatever their origin, they are among the most extreme objects known to exist. They're completely invisible. No light can escape their gravity. Instead, astronomers detect them by observing the stars and glowing gas moving around them. And despite decades of research, the true origin of these cosmic giants remains one of the universe's greatest mysteries. Black holes trap everything inside themselves. But what if there were an object that could never trap anything at all? An object that nothing, not even light, could ever enter? This is the idea behind a white hole. In many ways, it's the opposite of a black hole. A black hole pulls matter inward. A white hole would only push matter outward. Nothing could enter it. Everything would be forced away. The idea comes from Einstein's equations, which suggest that if black holes are possible, a reverse version might be possible too. But unlike black holes, white holes have never been observed. No telescope has ever found one. No experiment has confirmed one. For now, they remain entirely theoretical. Whether white holes are real, or simply a mathematical curiosity, is still one of the biggest mysteries in modern physics. Most planets orbit a star. Just look at our solar system. All 8 planets orbit the sun. But not every planet is so lucky. Sometimes the gravity of a passing star or another planet can eject a planet from its solar system. Left without a star, it begins drifting through the darkness of space. These are called rogue planets. Without a nearby star, they are incredibly difficult to detect. They experience endless nights, unrelenting cold, and eternal darkness. But despite this, some scientists think rogue planets could still hide oceans beneath thick layers of ice. You see, deep inside every planet is a hot core. On Earth, the inner core can reach temperatures of around 7,000 Kelvin. That internal heat could keep water in a liquid state beneath the frozen surface. If that's true, some rogue planets might even be able to support life. Entire worlds, traveling alone through the universe, invisible to the outside world, and unaware of what lies beyond.